And so I feel like the discussion is going to continue, but we'll have people talking about their experiences implementing data contracts in practice in the wild in the
Well,
near
and that's what
future.
I think we needed, because I think there's
Yep.
until you have some examples that you can point to, it's very much a straw man argument, right? Where
Yes.
I'm going to straw man the argument over here. Oh, this is a data contract, or no, this you're terribly wrong. This is a data contract, right? So it becomes, um, a bit of a bike shedding exercise over semantics, which those kind of conversations bore me to tears. Because they're not productive, right? Like, show me an example of what you're talking about, then we can talk about that example, at least set a precedent. I'm glad that Chad wrote this article. I'm also glad too, because it's more of a broader theme that we're seeing in data, where the practices of, I would say there's two big things what I'm noticing. One is pulling forward a lot of the practices that have been in software engineering for a while. So again, treating data like an API, which is probably what we should be doing, right? Having some sort of a contractual agreement about what is the data, what is the structure of it, what's the payload, if it changes, what can I expect? Like that's been done in software engineering for a very long time with APIs. I would say that's still very much a work in progress, by the way. If you've ever pulled data from APIs, I was dealing with this morning. It seems on the surface this should work. Reality is a bit of a different thing. But the other thing I'm excited about is I'm seeing a lot of approaches from supply chain and operations and lean and so forth being adopted in data. And I think this is a very good practice as well. Taking ops, for example, right? Ops has been around for a long time. It got its inspiration from lean. I'm very excited to see these practices being pulled into data. What this reminds me of, you know, it reminds me a lot of like basic stuff we've been doing in manufacturing for a long time, like bill of materials, right? Like, you wouldn't dare try and manufacture something on an assembly line without a bill of materials. You'd waste a lot of money. You'd probably get really strange things being built. You wouldn't get the one you want. A bill of materials is technically a contract, right? And so, and Matt, before the show, we were talking about your brother. He works with supply chain at at a
Yep.
pharmaceutical company, and
Yeah.
they got controls all up and down the line. And it's like, but for some reason we treat data differently. Like, oh, because it's data and it's ephemeral and you can't see it until you see it. And it's not a thing you can touch. It's not a thing that we think impacts lives, but it turns out it does. And we need to treat this as seriously as all the other things that flow in our world, whether that's ships or assembly lines or whatever, right?
Yeah.
So,
and just to pause for a second, we just had a really funny comment in the chats where Josh Gallant said, "Oh, great, data contracts, I'm out." Like, and I think that, and he's kidding, of course, but but I think that does capture some of the sentiment that I've seen from data engineers on LinkedIn and Twitter, where like you're saying, there's so many kind of straw man arguments going around, and like, what does data contract actually mean? Is someone about to pitch us a vendor like that solves a data contract problem? Like, these are the types of like surface level discussions I've been seeing, without going into the technical details. So so it is good to get your perspective on, what does a data contract actually mean? I think Chad Sanderson's post today actually walked through like a very technical implementation, right? Like, hey, we're going to have, log-based change data capture from a database, but we don't want to treat the CDC event as like a form of a data contract, and this database schemas themselves as like Chad calls them a non-consensual contract, right? Because the DBAs aren't there to serve the analytics users. And if you've ever actually seen a write-ahead log event from a database, that's nothing to pass on to an analytical user, assuming that like this is something that you can actually make sense of, right? There's a bunch of transaction metadata that's sort of useless. So yeah.
I mean, it's not the data contract we want, but it's a data contract we deserve right now. I'm talking about CDC and batch. Actually, you can fit that under, right? Because the way I would define a data contract is what am I expecting and what am I getting? That's literally what a contract is, by the way. Nothing more, nothing less. So, and in a lot of cases, what I'm expecting and what I'm getting when it comes to CDC or batch, these sometimes vary quite wildly. Not just in terms of payload, right? But I would say in terms of other things as well, like SLAs, frequency, that kind of stuff, right? Of course, you're talking about. So there's a lot of expectations that go into a contract. I think that the thing that Chad hit on was definitely a schema correctness and payload correctness and stuff, and it's definitely it's a big issue. I wouldn't say it's the only issue, but I think it's a good step. So.
And the fact that he makes the discussion code-based and tool-based, I mean, again, it's not about technology, but kind of getting humans out of the loop in some sense is what makes this concept really, really powerful. Or the fact that you have automated checks and it's not just like communication between teams with documentation. Documentation is great, but having tools that actually check that code is satisfying conditions, it's very similar to in Rust, right? Having type checking at compile time and making sure that you can block certain types of buffer.
Well, yeah, so I wrote in my
such.
notes. I think it feels like this is more of a well, it's not quite a compiler. It's more like it's more like how Python does, where it compiles at runtime. But still, it's a step in the right direction, right? Like, I wish there was actually a true compiler. And it reminds me a lot of like just doing schema migrations back in the day. Where, if you've done like Rails or Django development, it's like I mean, it's just, you can roll it back and all that kind of stuff. It's so I'd say inherently there's not like it's more, I think, of assembling a lot of the stuff that's existed to satisfy the glaring holes that have occurred in data, which is like most things in data. I feel like it's about 10, 15 years behind the software engineering world. They figured this stuff out because they had to, right? Data's always been sort of a second-class citizen, and that's and so you get the this is great, and hopefully things like this continue. So.
And both of you advise and you educate data engineers and data practitioners. Would you feel comfortable today going to a data engineering team and saying, hey, you should figure out how to build out data contracts in your organization? Or do you feel like it needs a little bit more materialization?
I mean, we talk about this in our book, actually. We talk about this in our book, and we say that the notion of a data contract is something you should take you should be doing, right? The low fidelity way is simply have regular cadence with the engineering teams that serve you data and just understand, and help them understand what you need. They should understand what you need. And if there's going to be a breaking change in an API, like, let us know. Because here's the thing, I like the technical implementation of what Chad proposed. The thing I think needs a bit more attention is, as data people, we also should know the meaning of the data. And if there's a change, what materially does this mean for the type of work that I'm doing? Like, if I just get a random new field in the data, for example, right, it satisfies the essence of a data contract, where it's backwards compatible, so it didn't break anything, right? But you introduce a new field to me and I'm like, I don't know what this is. What am I supposed to use this for?
Yeah, I mean, I think more broadly, if we talk about observability, for example, which is certainly related to contracts, that whole field is evolving very rapidly too, because just like Joe was saying, right, you can have, if you treat observability as just at the very fundamental level, I'm going to have some basic expectations, check schemas and check types and such. The reality is modern data is so complicated that that's not enough. So for example, if I see a big statistical change in my data, does that mean something changed in my business that I, as the data engineer or the data scientist, needs to be aware of? And I feel like this is a really good start for data contracts, and it's probably enough to start implementing. But I feel like there's also going to be a lot of evolution in this field. In fact, I feel what Chad has probably done, I mean, what they've probably done with this article is just kick off this whole discussion of very concrete technical details for implementation.
But the discussion Chad always points out, and it's what I agree with, and something we've been talking a lot about for a long time, is like push the work onto the the producers really need to be responsible for the integrity of the data at the end of the day. It drives me insane that analysts and data scientists and people in the consuming end of things have to clean things up, right? So if you look at it from a process a process standpoint, it's absolutely backwards the way we do stuff right now. I'm a process nut. Bookshelf is full of process engineering books and stuff, and it's like, this is the kind of stuff I've been trained to like sniff out, right? And from day one, I thought, okay, so like, why is it that I need to put in semantic correctness in my after my data warehouse, even, right? Semantic layer, that's absolutely stupid. That should be controlled up front, right? Any process, any assembly line, for example, like, you don't treat quality issues at the end. Like, you treat it at the source. That's how that works. And so that's what I'm saying. It's good to see like these examples of just proper operational thinking being applied to data, because it's just the order of operations. Like, we're literally doing things backwards right now as an industry.
Yeah, absolutely. And most of my experience and anecdotes come with working with large enterprises that have had mission critical databases in production for 20, 25 years. And now these analytics and data warehouse teams, evolving to the cloud and building SLAs into their operations. is a bit newer. Obviously, they've had data warehouses for a long time, but the way that they're using the warehouse is evolving, right? To build operational applications on top of the data. And a very simple question is like when the database team is changing a schema, or they need to do a patch on the database, how are they communicating to the data engineers who are the downstream consumers of that data? Like, how are you seeing that materialize in the market?
They're usually not.
That's just it, yeah. And one of my takeaways from this article is that building data contracts not just as documentation, but as technology actually facilitates change. So here's a classic example. I was working with a client once where we wanted to add a field. It was in the source data that they were getting from a SaaS platform. But basically the ETL team said, hey, this is going to take us 6 months. Well, why is it going to take you 6 months? Because they had to go through manually all of their pipelines and check that new field was not, that no one had put in a select star or something where they were going to break an assumption. Now, if in my CI/CD pipeline, I have automatic contract checking to say, hey, I'm attempting to deploy this commit that will add this field. Check everything downstream and see what happens. And if it goes through, then I can deploy. And if it throws an error, I'm going to see my CI/CD tool should tell me, hey, here's where the problem is. You have the select star here that's going to cause issues. I can then go to that team and work with them to get that fixed and gradually work through the issues quickly. And so I think a lot of the debate around contracts was how everything was going to get slowed down. But we really can't think of this as a way to go faster.
This also existed. Like Business Objects was doing this for like decades.
Yeah.
Right? You can make a change and you can see how it propagates before you implement it in your pipeline.
Yeah, that's a good point. So in other words, data contracts have been around for a long time.
Data contracts have been around for a long ass time. It's just you had to spend a lot of money on like one monolithic system to get it.
Yes.
Right now we're talking about sort of the new way of doing stuff, which is everything is code and again now it's just software engineering redux back into data again. But again, this is I was pleased to see this, right? Because it's for a couple of reasons. Chad's got some really good ideas on data, and I feel like this is just it. What I was happy about, it wasn't just another one of these articles where it's like data contracts, you must do them and stuff. It's like, here's an example of how we do it, right? Here's concretely how we do it at Convoy or wherever. And I thought that was that's what was really missing in the discussion. As Matt and I talk, because Matt and I rant about this all the time. It's like, but y'all just like shut up about this if you don't have like a concrete example of how to do this, because all it is like people just yelling at each other on Twitter and LinkedIn, and I'm like. And as Josh, sort of joked, but sort of not. I'm like, it's a fun argument, but I got other things to do. So, like, I got my own silly things to go argue about online with. So, yeah.
Yeah, absolutely. And I think it's one of those things where what's old is new again, and people are saying, hey, I didn't invent data contracts, but I came to the conclusion independently. So let's give people points for that too. And
well, I mean, it's kind of like saying like Leibniz and Newton came up with the calculus at the same time, right? And good ideas just have a way of fostering each other. And here's Matt and I have been talking about this a lot too, where it's like everything in the data world is a pendulum. When you get down to it, it's like we go to one extreme like ELT, where it's like it's easy to do, it gets a lot of adoption until you start realizing that this group over here that was yelling about discipline and contracts and all this stuff, they have a really good point, and so you swing back over here. Now everything's going to be semantically correct, but you're not going to be moving at the same pace you did over here. And so it just keeps going back and forth. I mean, Bill Inman had this in the original concept of a data warehouse. I mean, it was like he kind of had this actually figured out a while ago, but just to implement the way he did, it was just, a lot of teams don't have the rigor or the time to do it. But he actually nailed it in '89 with this too.
Can you elaborate on his approach there?
Yeah, so the original data warehouse basically was so the notion at the time was people were querying operational systems for analytics, which is obviously, especially at the time when you had resource constrained hardware, it's like that's a road to hell. So take the data out of these operational systems, put it into the data warehouse, right? But your data warehouse was integrating all the data along your enterprise, often in a highly normalized fashion, right? So you tended not to miss a lot of the details from those other systems. And then from there, provide data marts where you could provide analytics or however people want to consume it downstream. That was the essence of it. It was just integrating your enterprise's data in a subject-oriented, time variant, non-volatile way for the decision-making by management was the criteria.
The thing I'll add to that, one of the major themes in our book is that we call it enterprise data engineering. And by that we mean kind of all this old school control type stuff.
Same thing.
Old school
Old
control
school.
type stuff. Yeah. So, for example, like data management, during the big data era, no one wanted to talk about data management. No one necessarily wanted to talk about data lineage. All this stuff has come back into vogue, but in a new form where we think now about doing it in a collaborative, more distributed manner, not in like a centralized system, business objects that's going to do everything for you, or like with one central committee that manages all the data for the enterprise. That's not considered practical anymore. It's not scalable. It doesn't move quickly. And so that's another thing I love about this article. It's taking this data contract idea and saying we can do this in a distributed way by using CI/CD and other tools to facilitate communications between teams.
Mm-hmm.
And there's some really good comments going on in the chat. I want to get through all the questions. There was a new one from Josh Gallant and Suram, but David Jayatalake also came in with a really good comment as well about how enterprises have to agree that data is important first. Dave has a view that most enterprises won't be willing to do what it takes. My experience is that I think that they don't know the technical complexity of doing certain things up front. Like they'll agree to something like, oh, okay, like we're going to get real-time data or something very high level like that. But what does that actually mean, right? Okay, you have to size your databases properly. You have to make sure that you have the infrastructure to do proper write-ahead logging, all the capacity planning, all the data engineers who are going to be, keep these data contracts. So if you have real-time data, you're going to have business users who are going to assume that they can use real-time data to do certain stuff to the business, right? So now you have SLAs for that. And they just don't understand until, it's too late and they're in a fire drill. Like, well, oh, okay, we're not getting real-time data. Well, because of schema change, we broke a data contract. And how do we resolve that? Well, it turns out just resolving this is a 2 to 3 month effort. So how do teams, wade through those types of challenges?
I mean, it's interesting. So I felt like and Chad called this out in the article too, which I thought was good, right? Because it could potentially add a lot more work to dev teams. And as I wrote here in response to what David had written, a lot of this is hard work. And for a lot of people, extra work that I'm not getting paid extra for means I'm not going to do it, right? I mean, it's incentives and outcomes. If I have no incentive to care, then I'm like, well, thanks for the extra work. And I'll get to that like never. That's just human nature. And that's a lot of devs, right? I mean, if you look at like backlogs of issues in GitHub, for example, on any dev team, it's like they got a lot of stuff that could be getting done. And so it's about expressing the importance of like, how is this going to help your job, right? For one, the data team, you can work better with them, assuming you want to work better with them. I'll get to that point in a second. But it also means maybe you're not having to firefight data issues. But it comes back to, if you're a dev, like, do you even care, right? There are dev teams I've seen where they break stuff downstream. It's like, that's cool. You get to go deal with that now, not me. That's not my problem, even though I broke it for you. Because my job is to make changes to the database. Your job is to deal with whatever happened after that. I mean, that literally is what I see in most situations with dev teams right now. And that's why I said, like, you kind of need the human in the loop thing and the communication back with the dev team and build a relationship with them. And so when things break, that you do have somebody that cares and can, deal with this. Because otherwise, basically, cool, I have an API contract. This is what I wrote in LinkedIn in response to something too. I think it was Serge from SQL DBM wrote about data contracts and kind of the human element. And I was like, it seems like data teams, they have a lot of responsibility and very little authority to do anything, right? So if something breaks, it's like, cool, how do I enforce this contract? I know I have an API that supposedly does this, but say that something does break, say that it didn't get caught by this contract, then what do I do? What recourse do I have? In a real contract scenario, I have teeth. Data teams typically don't have teeth. That's kind of the crux.
And I think it speaks to the way organizations are structured too. Ultimately they have product teams and engineering teams, and those teams are trying to, win in the market against competitors. They want to ship fast. And I had I posed this question to the data engineering community as well. Like, if you're trying to make a certain release deadline, right, from an engineering perspective, does the data contract, does that stop the release? Or do we need to scope another month so analytics teams can respond to the change? Or is it simply a matter of communicating that, hey, we have to ship this, your pipelines are going to break, get ready, like batten down the hatches. How does that actually work in the real world?
I think there is a big question of commitment, right? So if an enterprise really recognizes that their data is so valuable that it can't be broken, then on the one hand, they need to commit the dev resources to get that job done. And on the other hand, they also need to commit to delays to make sure that things are shipped correctly. Like you would not ship a software release that broke the product for your customers, right? You would not do that. And so the question is, do you have that same level of commitment to the analytics side of the house? And I think to be fair, that partially is going to depend on what your business is. If that's like customer facing analytics that are mission critical, then yeah, absolutely. You need to
or
have
if
that
data is
level of
embedded
commitment.
in the product,
Yeah,
right?
exactly.
Mhm.
Yeah. If it's like dashboards that no one looks at, then maybe you don't delay the release for that. But I
Right.
think you need to have the conversation about what your level of commitment is.
Well, and as you
Yeah.
pointed out, John, too, it's like, what what is what is the company doing with data at the end of
Yeah.
the day? Like, what's the value they're getting out of it? And, um, I guess this is one way to find out really quickly how much value you're getting out of it. So it's what I used to do back in the day. I would just stop sending reports to people. And I find out who squeals, and if they think it's a crisis, then I guess it's important. But this, unfortunately, is not an observability metric right now for like data value for a company. And so the only way you could probably find out how important it is to see what happens. So
Absolutely. And ultimately, it'll work itself out over time where, the more critical data becomes in an organization, the data teams will get more leverage. And unfortunately, the way I've seen it play out is it does have to be through kind of fire drills and, people feeling pain, right? To really understand like, okay, yeah, we need to add this to our process to not break things. But I think now that teams are operationalizing data more than ever, and people are writing about data contracts. You have your excellent book, which I want to get into, right? I think now data teams are armed with more knowledge and frameworks that they can bring to the discussion and have like more executive alignment in terms of like, this is what we really need to do to deliver mission critical data operations.
yeah, definitely. And we're just getting started too. I mean, you got to understand, like, data is this very immature field still. I mean, it's been around, I think, since maybe the 60s, depending who you talk to. Kevin Hu would probably say it started with cuneiform back in the day, but I'm joking. But
Only partially.
only partially, yeah, debits and credits. But no, I mean, it's a very immature field. Software is immature, and look how much we're still trying to figure out with software. I mean, there's still new processes and practices coming up, but data up to a while ago, it was just sort of an afterthought, and everything they started cascading with the rise of data science and data engineering needed to support that, and we're still trying to figure things out, and so for me, I'm open to a lot of ideas. Like I think what Chad's talking about is absolutely killer. It's awesome. We need these conversations in this industry.
Definitely. There's one point in that blog post I wanted to ask both of you about before we move on to the next topic. So one of the interesting patterns that Chad has there is he's transforming the CDC events in a streaming SQL layer before sending it to downstream consumers. Now, this is a bit counter to the ELT paradigm where we just send raw data into the warehouse, transform it, from staging to raw tables to prod tables there. So what do you think about that as a design pattern generally?
I think it's still controversial. I think at this point, people haven't fully decided how this should work yet.
What should work?
The streaming data, in other words,
Okay,
real time
yeah.
specifically, right? There are a lot of practitioners who argue that you really shouldn't be transforming streaming data unless it's transformed in batch after the fact for specific reporting because it slows things down too much. But to realize that you have to work with the application team. In other words, application and analytics have to work together to design the model and the schema, or you're going to get data that's just a huge mess and you can't make any sense of. So in that sense, I definitely take the article's point that you're going to have to do some transformation with typical application data to make any kind of sense of it.
Well, we wrote about this in our book, and we've written about this elsewhere too, where it feels like when we talk about pendulums, it's been ELT for the longest time, but the rise of streaming is going to mean you see the rise of, I guess, ETL 2.0, right? Because especially if you're doing streaming transforms, maybe Flink or whatever, it's like, I don't see any problem with that. At the end of the day, are you just giving people what they want? Like, and the thing is, transformations also means you have to be very intentional about your data. The problem I see with ELT is, I'm borrowing this from Bill Inman. Really, the problem Bill sees with ELT, therefore the problem I see with ELT is it promotes potentially very lazy practices with your data, and so it just becomes a passive kind of a dumping exercise of your data. With sometimes you transform it, sometimes you don't, but a transformation I think requires you to be a lot more thoughtful about the data you're providing people. The good old days of saying, oh, we'll just collect all the data we need and we'll figure it out later, I think that's over. GDPR sort of kicked that one in the between the legs. So we'll see what happens from there. But I ain't got a problem with it. At the end of the day, it's kind of like I don't really have a religious argument on ELT versus ETL, to be frank. It's like at the end of the day, what are you doing with the data, and what's the best way to do that thing with data? So
totally agree. And I think this is also a side effect of kind of the DBT modern data stackification of the data landscape, where if your only tool is a hammer, everything's gonna look like a nail. And DBT is an amazing tool, and it adds so much productivity to the data engineering life cycle. So it makes it easier to do transformations in the warehouse, even if it's not always correct, even if it is going to introduce latency that won't feed your end users. Like I'll take an anecdote that I've seen where a team wanted to have an actual near real-time SLA between their transactional data and an operational database, and a operational analytical use case in their warehouse. And for that, they needed to do CDC, streaming SQL, model it's a deterministic transform. It's the same. They don't need to use historical data, right? They can just transform the CDC data in flight, have that operational view for their downstream consumers to get in near real time and say that, hey, we don't have to do all these batch transforms to achieve the same view. So and that comes back to your point about it's all about the use case. What are you trying to do with the data? So I think now ETL 2.0, as you mentioned, I think that's going to tie back to CDC and streaming SQL, and it's going to be good to have full context on all the tools and things that are available to you just to solve certain use cases.
Yeah, like I said, it's pendulums, right? We went the ELT route, and the thing is pendulum. You discover the shortcomings when you're familiar with something. You've been doing it long enough. Then you swing the other way, and then you fix those. And the ELT crowd would be saying, "Oh, you're missing out on all the fun we're having over here. Like, what about, whatever it is that people like about ELT, So, and there's some benefits. So, like I said, it allows data teams to, I'm sure everyone's seen the ETL workloads from back in the day or processes, and these things are a bit of a pain in the butt to set up. But the thing is, when they work, they work. I mean, I've seen ETL workflows have been running for years. They just do their thing. Why? It's because even it would take a lot to screw it up, I suppose. You'd have to be missing fields, right? But the thing is, a lot of these legacy systems, nobody really does much to them. At least the ones that I'm talking about that have been working for years. So it just depends.
Yeah. I do want to answer one of these questions since we're still adjacent to the data contract discussion from Josh Gallant. How do you follow up appropriately? The software engineers continually miss opportunities to communicate changes during those regular cadences.
Yeah, that's interesting. I mean, I kind of feel like the CI/CD approach is one way to facilitate this, where you basically have checks on things like schema changes, and they can't pass unless the data side of the house signs off on them, right? And they align with what analytics is doing. And I feel like if software developers have a few commits rejected and a few pull requests, then they're probably going to be motivated to make sure they're communicating with analytics. On the other hand, this is a real commitment, right? It's from the house, not just from the software developer. They need the resources, the time, in other words, to be able to commit to making this happen, right? Because just like piling on more work, just like Joe said, that's not going to fly. People already have too much to do.
Right. And I also think it's the implementation details too, that you're forcing onto the software, or I wouldn't say forcing, but asking the software engineers to adopt, right? So if it's me setting up Kafka and all the implementation that Chad said, that could fly. It might not. I don't know. If somebody is working on a really streamlined tool to make this happen, maybe Chad, you're working on a startup, that'd be cool too. But I think you need to reduce the amount of friction for this to happen, right? It just needs to feel like this is part of the process. It's painless to me to do this, right?
Yeah.
So,
And,
in my opinion,
you know,
this should be done at the code level, actually, where it's kind of done at like, it's no different than a schema migration you would do. That's typically what causes these issues, by the way, is when you do a schema migration. You know, this should just be one of the other tests that you do, is just like, does it mess up the data pipeline downstream? Right?
Yeah, absolutely. And that's why, vendor plug with Stream, we do give our users the ability to have granular rules on certain types of scheme evolution that propagates to downstream consumers, right? Because you can have certain tables that you want to propagate schema changes to. You might have other ones that said, okay, there's too many downstream consumers on this table that rely on the schema to be in this exact format. You're just going to break all their applications if we change the schema. So instead, we're going to have a circuit breaker in the ETL pipeline stop there, right? So I think this is ultimately, borrowing Michael Stonebraker's comment, which I apply to everything in data, is like no one size fits all. And teams are going to learn this independently. I do want to talk more about your book because there's so many good topics there that apply to what we're talking about. Yeah, and you have one passage there about, hey, learn the fundamentals and the core principles really well before trying to chase every trend, essentially, so you know which ones to scrutinize. Can you elaborate on that statement?
Yeah. I mean, I think that's part of why we sort of restated data engineering in terms of this data engineering lifecycle. It's what everyone has been doing for a long, long time, regardless of if it was like Oracle or IBM DB2 or Hadoop. It's like you're going to ingest data, you're going to transform it, you're interested in applications downstream, you're interested in serving data. And so that there's we expend so much energy talking about the latest and greatest tools in engineering disciplines that we often miss the point that the fundamentals actually haven't changed that rapidly. Like the fundamentals have really been this way since probably the 1980s, would you say, Joe? Or maybe 1990 or so, since the data warehouse concept was really codified.
It depends on how far you want to go back. I mean, they might have been earlier, depending on what aspects of the fundamentals you want to talk about. I mean, I'm reading a lot of old books right now, not like Shakespeare or something, but like old data books. It's interesting. A lot of the things that people like Cod and Peter Chan and other people talk about it's still relevant today. It'll probably be relevant 20 years from now, right? And so it was interesting. To kind of bring this home, I was talking to a person who's doing their undergrad in information systems yesterday, and that person wants to become a data engineer now. They found our book and thought it was very inspiring, and had a good chat. And this person asked, okay, so what do you think I should focus on? Should I learn DBT and Snowflake? And I was like, well, I mean, you could. I'm not going to stop you from doing that, but how are your coding chops, right? Like, how good of a software engineer are you? Do you understand data modeling, both relational and dimensional modeling? Do you understand how databases work at a fundamental level? Like these, do you understand like how networking works and security and all these other things? And I said, if I'm in your shoes, I would spend my time, I'd probably figure these things out first, the fundamentals, right? And I also encourage them, become an awesome software engineer. Like if you can like do software engineering really well, you got your pick of jobs coming out of school, right? Because you can, if you're really good at writing code, if you're really good at solving problems with code, like this is like the skill I would over-index on, because if you understand data, which he does, he came from an analytics background, but if you also can like be a kick-ass software engineer, you kind of have a lot of options at this point, right? And so, that's what I encourage him to do. But notice I didn't tell him, oh yeah, you should definitely go learn like DBT, Snowflake, like all these tools. Like I think that's this. Once you understand all the innards work, then you can start moving up. And he asked me about AWS too, and I was like, look, you can certainly go learn Redshift. If I'm in your shoes, I'm going to learn like how S3 works at like a very fundamental level, how VPC networking works, how IAM works, security permissions. I'm going to get into EC2 and like dork with that for a really long time and like break lots of stuff. Because if you can understand the building blocks, especially these cloud infrastructures, you can kind of do whatever you want after that. If you're starting at the top and sort of working your way down, especially in something like AWS, where there's a lot of, I would say, hidden complexity that you don't really realize until you start using it, you're going to be kind of hosed, frankly. So learn the building blocks. That's people are too enamored by technologies. And Matt and I talk about a lot about this, but it's like focus on the people and process part. The people part is like, just learn how to figure out requirements from people, learn how to ask good questions. The process part is like learning stuff like modeling, how do the underlying tools work, not the tools themselves, but what's the building blocks. And from there, you'll have a lot easier time figuring out technologies and how to use them in the data engineering lifecycle, like Matt pointed out. So
yeah. And that's a great point. So the fundamentals being, starting with software engineering, but one layer further, going to higher level systems like networking, EC2, dimensional modeling versus relational modeling. And once you do that, then the abstractions can carry over between any type of new shiny tool that enters the market with like their take on how you should do it. Like, because ultimately, every unicorn data company, they're really good at making things seem shiny and new and late and great, but you have to cut through the noise, right? And if you have the type of training that you mentioned in your book, then you're better armed to scrutinize which ones are really the best tool for your specific job, right?
Absolutely. I'd say too, it's interesting because the other great book in our field is Designing Data Intensive Applications by Martin Kleppman. I feel like that's sort of a sequel to Fundamentals of Data Engineering. So read our book first and read Martin's after that, and you'll just be good. You'll be a rock star ninja data engineer.
Exactly, and subscribe to what's new in data. And no, I'm joking. I do really recommend. I've recommended the fundamentals of data engineering in multiple of my posts. And I think it is one of those books that's super inspiring. Like I like to, ever since I was a CS student, I always like reading stuff that actually made me inspired to learn and inspired to build more and apply certain frameworks. And I really think your book, The Fundamentals of Data Engineering, fits into that category. The other passage, or I guess it was a chapter that I really liked, was talking about building loosely coupled systems. Can we chat about that one a bit?
Yeah, I mean, I think one of the big changes in data engineering, because the parts of the field really have changed, right? Like there are fundamentals that haven't changed, but the job day-to-day of data engineers, for many people who like work around data science and machine learning, has changed quite a bit in the last 7 years. I think building loosely coupled systems for resiliency and scalability has always been really important, but it's gotten way, way easier with various cloud technologies. And so, for example, I can pick, I can pick like a CDC ingest system, I can pick a transactional database, and then I can pick a queuing system basically, or a streaming event platform like Kafka or PubSub. And across these cloud platforms, I can just spin these up. They're turnkey. I can just enter a few lines of code and have them up and running. And all of these components can now scale and be resilient separately without being entangled too much with each other. And I think that's kind of how you want to think of the problem of modern data engineering. All too often, we see people trying to reinvent the wheel and kind of like build all these capabilities into their own services, and then they end up with a huge mess that doesn't scale and isn't very resilient. I don't know. What are your thoughts on this, Joe?
Yeah, I mean, loose coupling is definitely something I think we suggest. Sometimes let's take the counter argument though. When would we suggest tight coupling or a monolithic system, right? So there could be a time and place for this. I would say if it, if that system gets you going quickly for whatever reason, however you built it, sure, go for it. I don't know how often that would really happen, but evaluate the trade-offs and what you're trying to do, right? This comes back to good architecture. Good architecture is about evaluating trade-offs and making reversible decisions as much as possible that create a positive impact for you, right? So, if tightly coupled systems for whatever reason also works for you, I would say go for it. Just understand, right? This is the trade-off. You're incurring debt, and this debt will have to be paid off someday. Debt takes a lot of forms. It takes the form of your system stops working after a while or is very slow. I remember one tightly coupled system that I looked at. It started off running, we'll call it 12 hours. It's a pretty old school system. Then I think it ran took 48 to 36 hours to finish. And along that way, if anything broke, it had to start over. And so the business is already 2-3 days late in getting their data. And now if anything happens, it might never get it. And so now you have to rewind. And so this is sort of the danger of tight coupling, is that you it's a short-term win for potentially a very brittle, hard to manage system later. So evaluate that against the options of loose coupling. Again, I try not to be very prescriptive or religious in my suggestions to people. I think people are fully capable of making their own mistakes. I don't need to help them. So, yeah.
And I've seen that.
Find out and see.
Exactly. And I've seen this play out as well, where teams started with more monolithic data pipelines. I mainly work in change data capture and data streaming into warehouses and databases. And again, this is all about working backwards from the business problem. Surface to me as a support ticket, hey, we have some business users that said that they're getting too much lag, they're not seeing data within the time they expected. My first question is, okay, what are the tables that you're producing that have this real-time SLA? What are the resources, I mean technical resources, that you're committing to actually building this pipeline? And they say, oh, okay, we just have 1/8 CPU compute pipeline delivering all the table data, where even for the tables that don't have the 5-minute strict freshness SLA. Say, okay, well, there you go. Start decoupling your read from your write. Right, you can have one single stream from your database transaction logs, because you don't want multiple clients. But then you can, use like a pub sub model to dedicate more resources to the systems that actually have better data freshness SLAs. So I think that speaks to what you have there in terms of building decoupled systems, making sure that you don't have noisy neighbors, and you're able to correctly isolate those systems.
Mm. Yeah, that's exactly it. I'd like to point out this book too, Software Architecture, The Hard Parts by Neil Ford, Mark Richards, Pramod, and Zhamak, Data Mesh, actually. But I think it's a really good book. Neil Ford's books actually served, and Mark Richards' books really served us when we were writing the book. I think this is one of the best books I've seen in terms of how to go about diagnosing monolithic or tightly coupled systems, and providing blueprints for how to start decouple these systems, right? So there's a lot of patterns in here. I can't say that there's one pattern, but what you described really, right? That by knowing the patterns for untangling stuff, that's sort of how you would start getting it towards a path of a less hellish architecture. So hell is very easy to enter. That's the whole problem, and it's tempting. It seems like it's a great place to be until it's not.
And maybe you can correct me, but I feel like the one prevailing advice, that I see being relevant to everyone is really try to work backwards from the business problems, the things that, the leaders are committing to, and making sure that whatever your technical choices are, that you're actually able to meet those business goals. Because, my experience, I've seen it too many times where, the business goal is just set in stone, and they're just going to go with whatever, data tooling they have today and think that it's going to get the job done. And say, okay, it's physically impossible, right? You need to dedicate more people to it, or you need to dedicate more compute infrastructure. You have to do the types of things we're talking about, such as software architecture patterns to decouple the systems and isolate certain resources for higher SLA workloads. Like, those are the types of things that teams get to, I would say, more of a level 2 or 3 problem past just building the pipeline.
Oh, go on, Matt.
Yeah, and I was going to say in general, I mean, anyone getting into data engineering in 2022, unless they're working with like really old school on-prem systems and they know that that's just how it's going to be and there's going to be no cloud migration, should be spending a lot of time studying cloud technologies, and in particular what I would call like the glue or the bridge technologies. And that is just these like very basic infrastructure pieces like object storage, like pub subsystems that just tie everything together. And then that's what you should be using to build your systems to solve business problems, rather than like doing things from scratch. Because the nice thing, if I use object storage or a pub sub type system, that can have many uses, and it can scale up, and I can add subscribers. So instead of solving one problem, I solve one problem, and then I open the door to solving more problems in the future in a flexible way.
I'd say back to your example too of business requirements.
Yeah.
Say in 2022, right? Like, I'll ask the audience here, like how people who actually work at companies that have business initiatives. Some of us work at other companies, but okay. So say the CEO of the company says, "Oh, we need to be data driven, and this is our goal for 2023." Well, zoom out and understand what's happening in the economy right now, right? Is that person actually going to be there in a year? that just gave this mandate. You know, this is right now is sort of an interesting time where there's going to be a lot of culling of people that have given mandates, and then you get the new person in with the new mandate, and then the architectural decision you made, well, that gets trumped. Actually, we saw this happen we've seen this happen with many companies that we see. You get a new leader in, and well, what do new leaders like to do? Well, the first thing they like to do is they like to talk shit on the old person for sure. Like, that person was like definitely a loser. Now that I'm here, things are going to change, right? Like, no more of this crap, whoever that person was. No matter what it was, even if it was working, it's like, no more of that stuff. Like, we have to do things, I was hired to do things the way I'm going to do it. No new person in the world is going to come and say, let's definitely continue what the incumbent was doing before. Like, that made a lot of sense, right? So you're going to see a lot of turnover with executives and management very, very soon. And all of these people have every incentive in the world to kneecap whatever was happening before. So I would say don't get too comfortable with your architectures either, because things are probably going to be changing. That's reality. So all the tools
Love
you bought
the cold,
too.
hard facts.
It is what it is, man. And here's the deal. It's like all those tools you invested in, those contracts are going to be up for renewal pretty soon, whether you like it or not. So, and all the vendors are going to be calling you, trying to get your ear. You're going to be dealing with vendors. You're going to be dealing with executives who are just giving you a million different directions and stuff. That's the reality of it right now. Everyone wants a piece, and everyone has an opinion about how they're the best thing in the world. So.
But if you built your data architecture on fundamentals, it's going to weather the storm, right?
It will. It should. Better than the opposite. So. Or you can build a new architecture at your new job that you'll get. So,
Exactly.
You can be that new business leader who just wants to change everything.
Yeah, that engineering team sucked. I know what we need to do.
I mean, to be fair, the last person sucked, and I was dealt a bad hand, but I'm here to fix things.
Yeah. I mean, tell me a situation if you were hired in a job, would you ever say, "Oh yeah, I think the last person was great, and firing them was a huge mistake"?
I mean, maybe they quit because they accomplished their work.
Maybe they did, yeah.
Exactly.
It's just human nature, right? You always want to be the most attractive person in the room. So, anyway, on that cheery note, what else do we want to talk about?
Yeah, we're almost at time, but I did want to open it up to both of you. What's something what's a new data trend that you're actually interested in, and in terms of like what's new in data that you think is sticky and that people should actually be paying attention to?
I mean, I think the new things in data, it goes back to what Joe often says, what's old is new again. I think we actually are, real time has been around for a while. I guess this is kind of like softball, kind of calling out stream again, but I actually mean it. Real time has been
data integration has a great future.
Well, it does actually.
It does, yeah.
But I think real time is really going to spread. Especially we've seen like a Google Cloud platform on a variety of other platforms. Things Snowflake is doing. A whole bunch of tools are making real time way easier, and so I think it's going to be much more widely deployed in the next couple of years.
I'll echo that too. I mean, I've been studying and revisiting a lot of the ideas from Lean. Reading a lot of the original books and studying process improvement and value stream mapping from the lens of data, right? And like what needs to change. And it's interesting. Real time is one of these things where, okay, so in Lean, right, you pull, right? Like push is never something you do, and so pull. It'll be very interesting to see like how Lean practices start becoming more embedded in data, like. Batch is an anti-pattern, for example, right? And Lean actually batch and queue is like a cardinal sin. Consumers should be able to pull data when they the data they need when they need it. But waiting for stuff is just it's a cardinal sin. Things should move in a continuous flow. Real time, for example, right? I mean, that's kind of push or pull, whatever. But the whole point is, I think reducing the lead times between processes and shortening that feedback loop is something I'm very fascinated by. And in the last chapter of our book, we actually call this the live data stack, which is and that's why I'm excited about people like Chad, is he's seeing the light, right, where things should actually move up more towards the application layer. software engineering, and data engineering was more to help tighten that feedback loop between data generation and data consumption and usage. And so this is something that's very exciting. Real time is definitely the facilitator of a lot of this stuff, and that's cool. Coupling this with data mesh, which is the big idea right now. I was just in Australia last week, and I can't tell you how many people were talking about data mesh. It seemed like that's all people wanted to talk about. And so that's, I'm excited to see where that goes. It reminds me a lot of discussion of microservices and so forth. Again, software engineering applied to data, right?
Do you see real teams with data budgets building data meshes, or at least adhering to the patterns and saying this is a data mesh that we've delivered to our business?
I don't see it being done just yet. Again, that's our sample size of Matt and I, but I would say that the temptation is there, and I think the willingness to explore the ideas there, and so it'll happen with somebody. I just think what needs to happen is people need some examples of it working in the real world.
Yeah.
It reminds me of what Bill Inman actually said way back in the day. He told me about when he came up with the idea for the data warehouse. It took actually a while for that idea to take off. People kind of actually hated it. So, nowadays it's a common phrase, but when he came up with it, it seemed like there was a bit of an aversion. It took some time to build the momentum. I feel like so data mesh is going to be as well, where and data contracts, frankly, I think might be the same way, where you need proof, you need people doing it, you need people showing you how to do this stuff, right? And then it all takes off from there.
Yeah, and then people kind of like one phenomenon that happens is someone adopts the pattern successfully, and then they circulate around. They get other jobs. People from their team get other jobs and start spreading that around. And I think finally we're starting to see actual concrete examples of data mesh. Not a lot, but some where they're very successful, and that process.
We did it on the show the other day on Monday.
Yep,
yeah,
on Monday.
Omar from Roche, he talked about how he's doing data mesh there. Yep. And from what I understand, that was actually that was a project done by ThoughtWorks, who are the data mesh people. So that was, I believe that was one. And but those are things that I'm excited about. What's also interesting, I think, is this the convergence of data engineering with ML ops. I think is an ML engineering. I think it's sort of the other thread that I personally find very exciting. My background is data science and ML, and so that'll be pretty cool to see too. And then Web3 and blockchain and how that integrates. I'm kind of half joking, kind of not. I think there's going to be weird things from left field.
Yeah, and that's another area where streams are actually pretty interesting for building incremental models, right?
Mm-hmm. Yep. Yeah, exactly. Yeah, so new modeling, machine learning model paradigms are going to happen, and new data modeling paradigms. And that's the other area I've been paying close attention to. I'm working on a book on data modeling right now, which I think will be it's a highly contentious and I don't know field, but I got some ideas around this, and we'll see what happens. But data modeling, there really hasn't been a new approach to data modeling in the past 20 years. Data Vault was the last significant one, I think. But now you have streaming is sort of taking on a life of its own, and you have machine learning, and you just have a very large data life cycle and very new touch points that just didn't exist at the time. So
I think and this might be a conversation for another day, but I think fact tables are going to be pretty interesting, especially from a streaming context and being able to join data. And when you were talking about what's old is new again, Stream's founding team was from Golden Gate, and their inspiration for Stream, it was the CEO and CTO of Golden Gate, and their inspiration for this company was essentially in 2008, teams were starting to use change data capture to feed, Teradata and actually building, e-commerce applications and recommendation engines on the warehouse. And that was like very early stages of, what could be possible, but it did require a new architecture. And that's what we've seen built out over the last 5-10 years with the modern data stack, where I have this super scalable, hyperscalers where I can run warehouses, decouple compute from storage. And I think that's kind of the prerequisite we were waiting for to see streaming finally come back now and have its moment of, innovation and, adoption at mass scale.
Sure. Because it feels like, what happened with the modern data stack was when you look at in my opinion, the real fundamental changes, it took what used to be multi-million-dollar hardware and licensing and all this other stuff and brought it to the masses, right? Redshift was now 25 cents an hour for for a single node cluster back into 2012 or whatever it was, right? That was game changing, because before, for me to get the same power, I have to haggle with a salesperson and get into a license agreement, and Lord knows if I ever want to leave that license agreement, what's going to happen to me and my kids. So but it feels like that in a lot of cases that those same benefits are now being applied and democratized with streaming and so forth, where a lot of the stuff that these big companies, we're just kind of streaming first because they have to be. Now the same technology is going to be adopted, and new types of databases I think are going to come on the scene. DuckDB is also exciting, by the way. So yeah, there's a lot of stuff to be excited about.
It really is.
Oh man.
Let me follow into what you were saying, Joe, about modeling. I mean, I think part of the struggle with the modern data stack and a lot of the complaints you see on LinkedIn really just come down to a lack of thought leadership and a lack of training around those tools, right? So people are no longer signing like, $10 million Teradata contracts necessarily, but that also means they don't necessarily have the resources and training that the team that's getting that Teradata contract would have, and they need some help. And same thing with democratization of streaming. It means that we also need to rethink some things about data modeling. We need people to take that thought leadership and say, if you're streaming, you need to start thinking about your schema earlier. You need to think of your transactional operational schema also as an analytic schema. And so you need some new concepts that get injected and then to spread that training around too.
That's why I think ETL is going to become another big thing, because along with the rise of data contracts, you naturally actually inject a spot where data modeling actually makes a ton of sense. So I think that streaming data modeling is going to be a very interesting thing to watch, and I think it's going to happen more towards the application layer. Because it just makes a lot of sense, and I think there's going to be a newish type of paradigm resulting from that. Because right now the null hypothesis is you don't need to data model and just let schema evolution take its toll on you when you land the data, which I think is fine, but it also seems like a very strange answer, because it's like, well, it's basically it's a cop, like, oh, we don't deal with that actually. So I'm like, well.
And we see people starting to build applications on warehouses now, analytical operational applications, and reverse ETL and stuff like that. That's gonna have a SLA, right? Now it's not just pulling data into spreadsheets and doing some ad hoc analysis on the static data. Now you're actually delivering software with this. So I think that's gonna be another evolution that's gonna make the modeling so much more critical, and not just the act of modeling, but the SLAs around that model, right?
Mm-hmm. Oh, for sure. Yeah, that's exciting times. I think that when we look back on this era, it's going to be kind of one of the golden ages of data, where finally, we got past the hype cycle of data science, and it feels like there's a certain maturity happening in the industry, and it's very exciting to see.
Absolutely.
So it's overdue. Like I felt like the 2010s was basically a regurgitation of a lot of data practices we had been doing for the last few decades, but just doing it in the cloud instead. But there really hadn't been that many, I would say, significant advancements in thinking. So,
absolutely,
it's starting to happen. It's pretty awesome to see. So,
yeah. Well, I know we're a little bit over. Thank you to everyone who attended today's episode of What's New in Data. Joe, Matt, thank you so much for joining. And of course, everyone, I recommend The Fundamentals of Data Engineering. It's available on Amazon, on Apple Bookstore, wherever you can buy a book, you'll find it. But just give it a good old Google and you'll see where to get it. Joe, Matt, thank you so much for joining today.
Thanks, Sean.
Have a great rest of your day. Bye.
Take care.